Okay. Hello everyone. So again we are here with the straight line and लास्ट क्लास में हम लोगों ने देखा था कि स्ट्रेट लाइन में डिस्टेंस कैसे फाइंड करते हैं एक पॉइंट से एक लाइन के बीच में लाइक द शॉर्टेस्ट डिस्टेंस फ्रॉम अ पॉइंट टू अ लाइन हमने फॉर्मूला प्रूव भी किया एंड देन वी डिड सम ऑफ द क्वेश्चंस एंड द फॉर्मूला इज डिस्टेंस फ्रॉम अ पॉइंट टू अ गिवन लाइन लेट्स से इफ a line is given that is ax plus by plus c equal to 0 and sum of one of the point is given x1 comma y1. So the distance between these 2 points, distance between this point and this line is nothing but d. And this d is modulus of ax1 plus by1 plus c. This whole thing divided by square root of a square plus b square. Till here we already did in the last class and we have done some questions based on this topic. Today we are going to do some distance between two parallel lines, the shortest distance between two parallel lines. Now write the topic, the distance between. We'll see the proof also, distance between two parallel lines. Let us take two lines. So one line is like this and it has ax plus by plus c1 equal to 0. Two lines are parallel, it means the coefficient of x and y will be same. So this one will be ax plus by plus c1 equal to 0 and the second line has the equation ax plus by plus c2 equal to 0. What we need to do is we have to find the distance between these two lines, the shortest distance. This could be also a distance, this one is also a distance, but we need the shortest one. So we need to take the perpendicular. So let us find this distance. Assume it distance between these two lines is nothing but d. So the value of d is nothing but it's a modulus of c1 minus c2 whole divided by square root of a square plus b square. So how we are going to get this value, the distance value that is c1 minus c2 upon square root of a square plus b square. So let us consider the first line, one point on the first line like x1 comma y1 lying on the first line. Let us consider x1 a point x1 comma y1. Consider a point P that is x1 comma y1 on the line 1. On the line 1. Let us assume that this line, the first line, this one is the first line and this one is the second. So this point P is somewhere here. And this point P is nothing but x1 comma y1. If point P lying on the first line, ax plus by plus c1 equal to 0, it means it will satisfy that line also. So we can put this value there. So we'll get ax1 plus by1 plus c1 equal to 0. Now, we have already said if we have a point and the line, so distance between these two, I mean distance from the point to a given line is nothing but this one, d equal to modulus of ax1 plus by1 plus c. So वैसा ही हम अगर यहाँ पे कंसीडर करें तो second line is this one ax plus by plus c2 and one of the point is given. So here d is modulus of ax1 plus by1 plus the second line is c2. This whole thing divided by square root of a square plus b square. But from this equation, we can find the value of ax1 plus by1. That is nothing but it's equal to minus of c1. Now put the value of ax1 plus by1 here. So we'll get the d value, that is minus c1 plus c2 mod whole divided by square root of a square plus b square. Now we can take minus sign common and the outside modulus is there, so it will make it positive. So finally we are getting d is nothing but c2 minus c1, or we can take c1 minus c2 also, whole divided by square root of a square plus b square. So this is the proof of distance between two parallel lines, and the formula is d equal to modulus of c2 minus c1 whole divided by square root of a square minus b square. Now we'll see some question on this topic, like how to find the distance. So one question is there, that is find the distance between the point 4, 1. Find the distance between two lines. The question is find the distance between two lines, and the equation of line is given. The first equation is 3x minus 4y plus 9 equal to 0. And the second equation, that is 6x minus 8y minus 17 equal to 0. Now, first we need to understand this, how we are going to approach it. So here we have two equations, that is ax plus by plus c1 equal to 0. Another one is ax plus by plus c2 equal to 0. So here the coefficient of x and y in both the equation, we have the same value there. So if it's same, there is no issue. If it's not same, we need to make it same. So in the first equation, it's given 3x minus 4y plus 9 equal to 0. But in the second equation, it's given 6x minus 8y minus 17 equal to 0. So what we need to do, we have to change, or we need to make it same. So here in this equation, we can divide the whole equation by 2. So we'll get 3x minus 4y minus 17 upon 2 equal to 0. And second equation is this, 3x minus 4y plus 9 equal to 0. Now we need to find the value of C1 and C2. From the first equation, the C1 will be minus 17 by 2. From the second equation, we'll get the C2 value, that is plus 9. Now, D is modulus of C2 minus C1 whole divided by square root of A squared plus B squared. So we can find the A and B value from these two equations. So A is nothing but it's 3 and B is minus 4. Now put all these value here. So C2 is 9, C1 is minus of 17 by 2, modulus closed, and then square root of A squared minus B squared. So value of A is 3, so 3 squared, plus value of B is minus 4, so minus 4. So 9 minus of minus 17 will give you plus 17 by 2. And here 3 squared, that is 9, 4 squared 16. We'll get 25. So that will give you 5. In the numerator, we are getting 9 into 2, 18. 18 plus 17, that will give you 35 by 2. So finally, we can cancel this 5 and 35. So we'll get 7 by 2. The final answer is 7 by 2. The distance between these two line is nothing but it's 7/2. Okay. So now let me give you one more question, that is find the equation of the line midway between these two parallel lines. This time the question is something different, and they are not asking the distance only. They are asking the equation of another line which is situated in between those two lines. The question is like this: find the equation of the line find the equation of the line and the equation of line where and equation of line midway between the two parallel lines. Midway between the parallel lines, the line's equation is given, that is 9x plus 6y minus 7 equal to 0. And another equation has 3x plus 2y plus 6 equal to 0. Now, we can try this question. They're asking find the equation of line midway between the two parallel lines. The equation of line is given, that is 9x plus 6y minus 7 equal to 0. And another equation is 3x plus 2y plus 6 equal to 0. So now you have to understand the question first, how we are going to approach this. You need to assume three lines. Like equation of these two lines is given. One of the line is here, another line is here. Let us assume this one is L1. The first line has L1, second one is L2. But we need to find one new line which is situated in between these two lines. So the line will be somewhere here. And we can assume this line is nothing but L. Of course, the distance between these two lines, the L1 and L, is exactly equal to the distance between L2 and L. To apply all those concept and try to find this equation, you can take 2 or 3 minutes to solve this question. Okay. So again, you can observe these two equations. One of them is 9x plus 6y minus 7 equal to 0. Another one is 3x plus 2y plus 6 equal to 0. So if we are going to apply the distance formula here, obviously we need the same coefficient. Coefficient of x and coefficient of y should be same. So you can see here it's a 3x, it's 9x. So we need to divide the first equation by 3. So we'll get 3x plus 2y minus of 7 by 3. And this is equal to 0. 0 by 3 will give you 0 only. The second equation is this. So I'm writing here 3x plus 2y plus 6 equal to 0. We can assume the equation of this line, the required line. We can assume it like y equal to mx plus c. Equation of this line is nothing but y equal to some mx plus c. We need to convert these two lines also in the form of this slope-intercept form. So if we are going to take y value here, so we'll get y is nothing but minus of 3 by 2 times x. And now minus 7 by 3, when we are going to take it right hand side, it will become plus 7 by 3 and 1, 2 is here, so plus 7 by 6. So one of the equation is this, y equal to minus 3 by 2 plus 7 by 6. Second equation is y equal to minus of 3x or 3 by 2x minus 6. Now all the three equations are in the same form, that is y equal to mx plus c. So if we are going to divide it by 2, so this will also become 6 by 2, so that is minus 3. And here it's 7 by 6, yeah, it's correct. Now, what we need to do is we have to find a value, or we can find the slope here. The slope is nothing but m, or the coefficient of x is nothing but minus 3 by 2 everywhere. So m is minus of 3 by 2. And from the first equation, we'll get C1. C1 value is nothing but plus 7 by 6. C2 is nothing but minus 3. Now we can apply the distance formula. The distance between L1 and L is exactly equal to the distance between L2 and L. To apply this, distance between line L1 distance between line L1 is exactly equal to L1 and L is equal to distance between line L2 and L. Now, the distance between two parallel lines is nothing but the difference of their constant term, that is C2 minus C1. Here the constant term is C. Here the constant term is 7 by 6, and this one has minus 3. The distance between L1 and L is nothing but modulus of, or you can say the distance between L1 and L is nothing but difference of the constant term, that is C minus 7 by 6. Or if we can assume it C1 also, C minus C1 upon square root of 1 minus 1 plus m squared. We can assume it, the first line equation has y equal to mx plus c1, and this one is y equal to mx plus c2. The distance is nothing but c minus c1 whole divided by square root of a squared plus b squared. So 1 is squared. If we are going to see b squared, it will become minus mx. So plus of minus m whole square. Again, the distance between L2 and L, this will be nothing but C minus C2. Modulus of C minus C2 whole divided by square root of 1 squared plus minus of m squared. Now you can observe it that both side has the denominator same value. In the denominator, both sides same, so we can cancel it. Now, if we are going to simplify it further, we'll get modulus of C minus C1. Now we can put the value of C1 and C2, that is 7 by 6. So C minus 7 by 6 equal to modulus of C minus, the C2 value is minus 3. So minus of minus 3. Now we can open this mod or simplify it one more time, like C minus 7 by 6, and the right hand side value will become C plus 3. Minus of minus 3 will give you plus 3. Now we can open the mod. So when we are going to open the mod, we will get plus minus both, because inside the mod, it can be negative value also, or it may be positive also. So when we are going to open the mod, we'll get one side plus minus sign. So C minus 7 by 6 will give you plus minus C plus 3. Now there are two equations, that is, one is C minus 7 by 6 equal to C plus 3. If we are going to simplify it, so C and C will get cancelled. So minus 7 by 6 equal to 3. Minus of 7 by 6 equal to 3, which can't be possible. So we can't take this condition. So only the second condition will satisfy. And that is nothing but C minus 7 by 6 equal to C plus 3. Okay, we already taken C plus 3, so minus of C plus 3. Now, simplify it further, we'll get C minus 7 by 6. Here you will get minus C minus 3. So take this C to the left hand side, it will become plus 2C, and this one will become minus 3 plus 7 by 6. So finally, 2C equal to minus 18 plus 7 whole divided by 6. So finally, we are getting minus 11 by 12. The C value is nothing but minus 11 by. Now we got the value of C, the constant term. We already have the slope, that is M. Because it's a parallel line, so all the line will have the same slope, that is minus 3 by 2. We have the intercept. We can write the equation of a straight line, that is nothing but y equal to mx plus c. So the m value is minus 3 by 2 and the c value is minus 11 by 2. So minus 3 by 2 times x minus 11 by 2. Now we can simplify it further and write it in a standard form. So we will get 2y. We can multiply the whole equation by 2. We'll get 2y minus 3x minus 11. 3x plus 2y plus 11 equal to 0. So this is the required equation. 3x plus 2y plus 11 equal to 0. And it's exactly lying in between these two lines, L1 and L2. If you want, you can go through the solution one more time. Here, we converted those two equations in the form of y equal to mx plus c, and we assumed the required line, that is y equal to mx plus c, and the given two line, that is y equal to mx plus c1, and another one is y equal to mx plus c2. And we converted this given line in the form of this, and we found this c1, that is plus 7 by 6, and c2 is minus 3, and the m value is minus 3 by 2. The next step is distance between those two lines. Distance between L1 and L and distance between L2 and L, both will give you the same value. So that's why it's equal. And we found those value by using this formula. The distance between two parallel lines, modulus of C2 minus C1 upon square root of A square plus B square. So when you are going to apply this formula, you will get this. denominator has same value. That's why it will get cancelled. After further simplification, we reached here, and when we are going to remove the modulus, we'll get plus minus sign. And when we are taking plus sign, the C will get cancelled, and we got one relation, that is minus 7 by 6 equal to 3, which is not correct. We can't take negative value is equal to positive 1. So we can't take that assumption, and so the second condition will satisfy, that is 7 C minus 7 by 6 equal to minus of C plus 3. After simplification, we'll got C value, that is minus 11 by 2. Now we have C and M. We put these two value in the standard equation of a straight line, that is my y equal to mx plus c. And after the further simplification, we got the standard equation, that is 3x plus 2y plus 11 equal to. So this is the final answer. Now we can do some more questions. Write one more, that is find the coordinates of point. Try one more question, that is find the coordinates of the point. Point on the line x plus y plus 3 equal to 0. Point on the line. And the equation of line is given, that is x plus y plus 3 equal to 0. And it's given whose distance from the line, And the second equation of second line is x plus 2y plus 2 equal to 2y plus 2 equal to 0. And the distance is also given, that is root 5 is root 5. So we need to find the coordinates of the point on this line. This time they are not asking the perpendicular distance. The distance can be any distance they are asking, like if we have two lines, and obviously these two lines are not parallel. One of the coefficient of y is 1, another one has 2. So both the line must be something like this. One of the lines should be like this, another one like this. And they are asking the distance between these 2 points. Okay, distance is given. They're asking the points. Distance might be like this. So you can consider this one as perpendicular one. This is given, that is root 5. And one of the equation, the first equation of the line x plus y plus 3, you can assume this one, and another one is x plus 2y plus 2 equal to 0. You can assume for the second line. Take 2 minutes and try to solve the question and try to find the coordinates of the point on this line, x plus y plus 3. Okay. So first we need to think about the approach, how we are going to solve this case. So if the equation of this line is given, that is x plus y plus 3 equal to 0, and the second line has the equation x plus 2y plus 2 equal to 0, and they're asking the point, they're asking this point. And obviously we need to consider these two are the perpendicular line. I mean perpendicular distance. This one is also perpendicular. This line might be crossing like this. If you can see, it might be like this. It's not in the same plane. It will be on different plane. It might be in the some xy plane, and the second line yz plane में हो सकता है, या फिर it can be drawn in the yz plane or xz plane. It means it's not in the same plane. It's not in 2D. It's a 3D picture. So definitely these two are the perpendicular one. So हमें P points को find करना है. So what we need to do is we have to find the general points for this P. So how to find the general point? We need to consider that point P is, we need to assume it, point P has the value that is x1 comma y1. And if point P is x1 comma y1, so this point definitely satisfying the given equation because the point is lying on that line. So this x1 comma y1 will satisfy this equation. So x1 plus y1 plus 3 equal to 0. So now we can find the y1 value in terms of x1. So y1 is nothing but, you can write it, minus x1 minus 3. Now we have the p coordinates, that is x1 comma y1. So we can write this x1 comma y1 is nothing but, now we got it, x1 comma minus of x1 minus 3, or we can take minus sign common, so minus of x1 plus 3. We have the coordinates like this. Now what we need to do is, we need to find the distance from this point to this line, the perpendicular distance. And now for that we have the formula, that is d equal to modulus of the given point is a x1 y1, and the equation of this line is given, that is x plus 2y plus 2. Now we have, instead of x1 y1, we have this point. We can write it here, that is x1 comma minus of x1 plus 3. Instead of using x1 comma y1, now we are going to use this value. So distance formula is nothing but ax1 plus by1 plus c mod whole divided by square root of a square plus b square. So what we need to do is, we need to put these two values here in the given equation. Instead of x, x1 is there, plus instead of y, minus of x1 plus 3. So 2 times minus of x plus 3, 2 times minus of x plus 3, or we can take a curly braces here. 2 times minus of x1 plus 3 plus 2. This whole thing divided by coefficient of square of coefficient of x plus square of coefficient of y, and that is nothing but 1 square plus 2 square. And the distance is given here. This distance is given here, that is root 5. Now what we need to do, we have to put the, instead of d, we need to put this root 5. When we are going to put root 5 here, we'll get root 5 equal to modulus of x1 minus 2x1 minus 6. x1 minus 2x1 minus 6 plus 2 whole divided by square root of 1 square plus 2 square, that is 1 plus 4. So it will give you 5. So x1 minus 2x1 will give you minus of x1 minus 6 plus 2. This is minus 4 whole divided by root 5. Now we can do the cross multiplication here. We'll get Modulus of minus x1 minus 4. We can take minus sign common and its mod is there. So it will become positive. So we can write it like x1 plus 4 mod into root 5 into root 5. So finally, we are getting x1 plus 4 mod equal to 5. So we can remove here the modulus. So we'll get x1 plus 4 equal to plus minus root 5 into root 5 will give you plus 5. So x1 plus 4 is nothing but it's a plus minus 5. Now again, two conditions are there. One is x1 plus 4 equal to plus 5. Another one is x1 plus 4 equal to minus 5. So when we are going to take plus 5, we'll get x1 equal to plus 1. When we are going to take x1 plus 4 equal to minus 5, second condition is x1 plus 4 equal to minus 5. So we'll get x1 equal to minus 9. Now we got two values. There are 2 points from where we get the distance, that is root 5, and it will satisfy the condition. The point will be lying on this line. So when x1 is 1, now we can put this value. So when x1 is 1, y1 will be minus 1 minus 3. For x1 equal to 1, y1 will be minus 1 minus 3. So finally, y1 is nothing but minus 4. Second one is for x1 equal to minus 9, so y1 will be again minus 9 minus 3. So finally, y1 is nothing but it's minus 12. So there are 2 points which is satisfying the given condition. One of the points is 1 comma minus 4. One of the points is 1 comma minus 4 and another point says minus 9 comma minus 12. These 2 points are there, which is lying on the given line, that is x plus y plus 3 equal to 0, and distance from that point to this given line is root 5. Yeah. These two are the, I think we have done. So x1 is minus 9, and here we already have one more minus. Minus of minus 9, it's not only one. X1 is minus 9, and here we have one more minus sign. So minus of minus 9 minus 3. So it will become plus 9 minus 3. So it will give you plus 6. So this is minus 9 comma plus 6. So these two are the required answer. 1 comma minus 1, 1 comma minus 4, and another one is minus 9 comma 6. Okay. There is one more question. Okay. 3 lines are given. Or we can take the simpler question. It will be little bit difficult one for now. So we can take the different one. So two sides, equation of two sides are given. Two sides of a square. So equation of two sides of a square. Sides of a square lie on the line. The equation of line is it's x plus y equal to 1. Now it's working. So two sides of a square lie on the line. Two sides of a square lie on the line. And the equation of lines are given, that is x plus y equal to 1 and x plus y plus 2 equal to 0. Somehow the pen tab stopped. Lie on the lines, and the lines equations are given, that is x plus y equal to 1, and another equation is, that is x plus y plus 2 equal to 0. Then what is its area? Second equation as x plus y plus 2 equal to 0. Then what is its area? What is its area? We can take one minute here, but it's a very simple question. We have two equations. I mean, equations of two lines on which one is square is lying. Two sides of the square is lying on those two lines. So it's a very simple question. You just draw the two lines and find the distance between those two lines. You will get the sides of a square, and then you can find the area. It's a very simple question. You can take 1 minute and do it. I'm going to help you with the diagram. You can just draw these two parallel line like this. And one square is here. Or we can take the read this one. So square is like this. So clearly we can see here two sides of this square lying on these two different lines. One of the side is here, another side is here. Now, not look like a square, it's a rectangle, so we can make it a square. So now what we can do is, clearly the sides of this square will give you the distance. It's nothing but it's equal to exactly the distance between these two parallel lines. And we know how to find the distance between these two parallel lines. We have the two equation of one line is given, that is x plus y equal to 1. Another one is x plus y plus 2 equal to 0. So we can make it in the same form. So we need to take this plus 1 to the left hand side. So it will become minus 1 equal to 0. And second equation is x plus y plus 2 equal to 0. Now we can easily find the value C1 and C2 to find the distance between these two lines. We can assume the distance between these two lines is nothing but some d. So d will give you, first we can find the C1 and C2. So C1 is nothing but -1 and C2 is nothing but +2. Now we can find the d value here. So d is distance between these two parallel lines will give you C1 minus C2, or you can take C2 minus C1 divided by square of or sum of square of coefficient of x and y. So C2 minus C1 will give you 2 minus of -1 whole divided by square root of coefficient of x is nothing but 1. So 1 is square. Coefficient of y is again 1. So 1 is squared. So 2 minus of -1 will give you +3 divided by 1 plus 1. So root 2. 3 by root 2. Now we have the d value, that is 3 by root 2. We can easily find the area of a square, that is nothing but square of sides. So area of a square, that will give you d square. So 3 by 2 root 2 whole square. So it's nothing but 9 by. So final answer is 9 by 2. So this is the simplest question. 9 by 2 is square unit. I think the time is up, so I'm going to wind up here. So this is the last question for today. Okay, thank you. Thank you for joining.